All right, today I'm going to do this particular section on, actually I'll be trying to cover a few different sections, right? So initially I'll be touching on NLP, natural language processing, right? And I'm going to do experiment sort of exercise using TensorFlow. So we'll be learning both these concepts together, TensorFlow as well as Google Colabs. So we're learning few concepts in one single go. And apart from that, we'll be using again a deep neural network. So there also you'll be learning quick few things about the next neural network that you're trying to learn. Okay. So initially we'll have a quick idea about what is this natural language processing, right? So natural language processing is, guys, everywhere. You will find natural language processing is used many places. So there are so many different topics when you talk about natural language processing. We have speech recognition. So you have things like Siri, Cortana, and things like that. So they use speech recognition, and also so that's also is a natural language, right? And then we have things like document summarization, right? Document summarization, right? Summarization of the documents. Okay. And then you find things like machine translation. So there are so many case studies when it comes to NLP, machine translation, and also you'll find things like spam detection that can be useful for cybersecurity. Spam detection. Okay, and then name entry recognition, questions and answering, Q&A, right? So when you do Q&A, so bots, chat bots, all these things, and also predictive typing. So that this goes and goes together, right? And also initially, of course, probably we have seen many places things like Cortana, right? So Cortana is famous. So Cortana is one such example. So Microsoft OS supports the Cortana engine, so it uses and identifies natural voice, where you can set reminders, ask it to open apps, send emails, play games, things like that. So it's quite interesting. And also you find Siri, right? So Siri is also quite famous, right? So Siri also can do all this, most of those things, text, sending text, and it's connected with the iPhone and even the iPad. So you can send an email, set a timer, take a picture, open an app, right? So so there are so much of things that you can do with Siri as well. And then of course Gmail is really popular. It's out there. So it has the spam filtering capabilities and all these things, right? So Gmail also is something very useful. Right. So when you're supposed to now do natural language processing, so these particular applications, products do use natural language processing a lot with machine learning. So there is a famous library out there which is called NLTK. Right. So we are not using it right now here, but try to understand NLTK is having all these things in it. Natural language toolkit. Basically, it uses Python, right? So Python programmers do use it. So they have a lot of corpuses. Actually, they use text corpuses and lexical resources, right, for text processing, right? So they do things like a lot of things. They support a lot of things like classification of text, classification, and also things like tokenization, right? And stemming, tagging, parsing, and all these things will be done using NLTK. So basically you can write a command like import NLTK, right, would basically give you, sorry, NLTK should be TK, will give you the ability to use the library, right? And there are several examples that you have to understand when it comes to like concepts, when it comes to natural language processing. So the first one of them would be sentence tokenization, right? So the first would be sentence. So sentence tokenization. So basically what it does is it tries to get a paragraph. From a paragraph, it tries to divide the strings into different sentences. But remember, so basically you can do through split it through a punctuation mark. So that's the normal way of doing it. But in English, the problem is there are stop characters, right? Stop characters, right? So when processing a plain text, you have to find out the boundary. So it might not be that easy to understand, how this thing works altogether. So as an example, if we try to get a sentence, so let me try to bring a sentence here. So something like this, backgammon is so actually I'm taking this text from one of the articles from towardsdatascience.com, so I'll be sharing that article later, right? So if you look at this sentence, so you can clearly see there are full stops, so from them you can tokenize the sentences. So for that you can basically write the code in this structure. So let me give you the coding. So this would be the code that we can use. So you can get the text and you can use the NLP case sent tokenizer, and then you can get the print. So basically once you run the code, you will get output like this, where it will break things into 3 sentences, as you can see here. So without much of a problem, they can do the sentence tokenization. All right. And then, of course, we have the second one. So it will not be enough to do only sentence tokenization. You have to do word tokenization as well. So that's a different problem. Try to understand, it's a different problem. So the problem of dividing string into written language into separate words. So in a lot of languages, space is the best approximation to the tokenizing the words. The problem is if you can have the problem is split by space to achieve the wanted result. But some English compound nouns are variable written and sometimes they contain space. Even variable, these compound nouns also have spaces, so you might get it wrong. But still, it might not be the hardest thing to do. So you can use a particular function here. You can use the word tokenize function, which can bring down the needed output without much of a hassle. So see, as you can see, see that this won't be the hardest problem to solve even, right? So see, this will give the all the words in the document, right? So you can see the words are being tokenized properly, and probably sometimes this dot is also recognized, full stop is also recognized as a word. So those can be some of the concerns that you have. Yeah, so the next one is actually called text, right? It's called text lemmatization, right? Lemmatization, and there's another word comes in called stemming. So these words also, or these components are also quite important. So the thing is like this. So when it comes to English, there can be different forms of words like drive, drives, driving, right? So these are some of the examples. Let me try to bring it in. Okay, if you get this one, right? So if you get these words, so these all have the related words, no? Similar meaning, right? You can get another example. See, we look at this one. This is also very similar in nature. Okay, nation, national, nationality, right? So what we try to do from when we have such words in a document, so we try to identify what are those, and then that will result in important identification of similarity, right? So these are some other examples. So if you can get this done, right? So on the top example, so you can see am, are, is to be represented as be, and whereas dog, dogs, dog with apostrophe and apostrophe again can be a dog, right? So if you try to do this lemmatization and stemming, you can get your output in this nature. So which will solve a lot of problems. All right. So we don't have to worry about all these other things which is there. Okay. So this is basically a normalization. So if you try to understand what is this, it's basically a normalization, right? Normalization of the words used, right? So if you want to give kind of a definition for stemming, right? So if you want to give a definition for stemming, so this would be the definition. Right. So stemming usually refers to a crude heuristic process that chops off the ends of the words in the hope of achieving the goal of correctly most of the time. So basically it's a normalization. So lemmatization also would have a kind of type of similar meaning. Okay, take it down. So usually refers to doing things properly with the use of vocabulary and morphological analysis of words. So I hope that you got the understanding from the previous examples. Right, so we'll not go too deep into it. So I just wanted to take you through it quickly so we'll get the base idea. And then, okay, so the next concept we'll understand is stop words, right? So these stop words are also quite important, right? Because these would be filtered out of a processing text. So as an example, and the, so those are stop words, right? So if you look at things like and, right, and also the, and also regard to be stop words. So, but only thing is you can't have a universal list to create stop words. So, but there's a stop words library used in NLP, which basically can be downloaded into the which you can download a few minutes to use in a particular program. So, and if you want to find a list of stop words, you'll be able to find it through this. So you can see these are seems to be the stop words, right? Sorry, this is a example of words, and you can run a code, and you can get the no, yes. So these are the stop words, and you can use these stop words to as a reference to remove it from a program code, right? So, and apart from this, there are other concepts we use, things like regex, which can be again useful because these are also kind of pattern identifying, pattern matching commands that we can use in NLP, right? So let me take a set of regex commands. So as you can see, dot means, so I think you have learned this in many places, matches to any character, /w matches to a word, d matches to a digit, so likewise it can go. So this can be quite useful when you want to identify and filter things out from a natural language text. Right, now comes to an important one. Now also when you're going to do it, now you know these techniques can be used even without using machine learning, but when it comes to ML, there are some requirements. So the first requirement for machine learning is if you want to do a natural language type of problem, to solve a natural language type of problem, you need to find this very important very important thing. Let me take it. So very important technique called bags of words, right? Bags of words. So we don't need this so bags of words. So bags of words is a kind of a process of converting your text, right? Of course, you have a lot of text when you input, and you have to convert this to a mathematically friendly format for the machine learning algorithm, even to feed to deep neural network, it has to be with some quantified values. So basically, you have to convert it to a vector. Previous example also, in our fashion example, Emily's fashion example, we converted everything to a array, right, or a vector. So that's what you do from bag of words, right? So this is a popular and a simple feature extraction method. So yeah, so this is basically what it does. It basically do feature extraction, right? So that's the use of bag of words, right? So hope it's clear to all of you. And basically there are two things that you do when you're dealing with bag of words. First of all, we develop a vocabulary. So you have to develop a vocabulary. So that's the first step, vocabulary. And so basically this can be similar to set up tokens, right? And then you get the measure of presence. So to find out where the words are, measure of presence, how many words are presence, measure of the presence. Yeah, so that's basically it. And then yeah, similar documents and similar yeah. So basically to do this process, we can take step-by-step mechanism. The first step, of course, is to load the data. So when you are going to do the bag of words, you have to load the data, and then once you load the data, you can split it to parts, tokenize it, find the vocabulary, and do all these things, right? And then you can design the vocabulary. So you have to, so once you load the data, you can design the vocabulary. Okay, you can design the vocabulary, and of course after that, so you can create document vectors. So you have to create the document vectors. So that's only when we are ready to take it to the machine learning process, right? So you will probably will get, once you create the vector, you will get something similar to, something similar to this. All right. So this is like the structure of a document vector, right? So you can find the words and the presence of the words. So basically that's what you do. And basically it has to ignore the case of the words, ignoring punctuation, removing stop words. All this process has to be taken care of. So once you get that bag of words, then we can use it as a vector, and we can input it to a machine learning model, right? So but understand, once we run our code, we are going to basically omit all these things, because the TensorFlow library supports all these things, so we can do things faster, right? Yeah, and also we use another concept called TF-IDF, which is also something that you are supposed to know here. So sorry, TF-IDF. So the base concept of this TF-IDF, so to understand, is the problem with scoring word frequency. The word frequency, the most frequent words in the document start to have the highest score. So because of this problem, the frequent words may not contain that much as information gained. To solve this problem, we use something called term frequency inverse document frequency. So the statistical measure, which I'm not going to go detail into, but when you're going to do, solve a natural language problem, this might come handy to you, right? So try to understand this sort of functionality can be used when you are supposed to solve that particular issue. All right, so now we'll try to solve our problem, right? So for this, like I told you, I'm using Colabs. All right, Google Colab. So I can use PyCharm also, but because I want to introduce Colab to you, I'm doing this with Colab. And this particular experiment that we are trying out is already available in Google Colabs. So you can get it down from there as well, right? And then try to understand in natural language processing, if you get words, like as an example, uh, very similar words will be there. So if you get something like amazing, and also excellent, right, and also things like awesome. So all these words means something very much similar. All right. So what we have to do is, when we have to solve a problem like this, right? So we have to convert. There's no way that we can feed this, like in bag of words we have identified that. That's something that I haven't covered there. So we cannot basically feed this to a neural network. So you have to convert this to a vector. So that's what we discussed earlier. So for that we use a very popular method in NLP called word to vec, right? So word to vec. So it's so famous. Everybody in NLP knows about word to vec. So basically you can get a number like 1, 2, 4 for awesome, sorry, excellent, amazing, excellent. You can get 1, 2, 3, right, and awesome 1, 2, 6. So one thing that you understand is they are much closer together, no, because it gives more of the same meaning, right, same meaning, right. So now what we're supposed to do is we have to convert it to a basically a vector. So we can get into a vector like this 0.2, 0.5, 1.1, right? So these are converted into a vector. So I'm not going to explain how this was converted, but this is what with the output. So excellent also because it's a very similar word in meaning, so you get a very similar set of numbers. So maybe I can put something like 0.4 here, but almost the same. And awesome also won't be that much different. We put 0.2, so 0.4, and probably 1 or 0.9 or something. Yeah, so that gives you understanding that you can find very similar type of vectors. And yeah, and also once you do this process, once you convert this process, the number, sorry, the words means lot of things, because it can use in algorithm, mathematical algorithm, and also you can do these basic things, right? As an example, if you get king, the word king, and if you reduce men from it, all right, and then if you add women into it, what would be the result? What do you think would be the result? So yeah, so you can guess even, okay, that is queen, right? So that is queen, okay, so that's possible to identify. So see, like that would be one of the things that you can do once you have the right format. Another example would be another example would be if you get USA, United States, and then you reduce Washington DC, right? You reduce Washington DC from it and add Germany into it. So these are nice problems. So you will define it as Berlin. Right. Okay. So those sort of things can be captured using using this model, right? Okay. And if you try to represent this now, say as an example, if you get end of the day, you will get a word less or sentence saying this life is great or sucks, whatever. Right, so once you want to process this, now first thing you have to do is you have to convert this to a word to vec, right? All right, so then you get this vector, say 0.2 and 0.1 and 1.2, and so there's a vector of length of 20, right? So these are called embeddings. And now all this can be, so once you have these embeddings of the vector, now the problem is quite easy for the machine learning engineer. So now we have the embeddings, so this can be applied to a nodes of a layer, input layer of the neural network. Alright, so that's the input layer, and get connected to another layer, and finally, right, so natural language say this one, our problem is like, actually what we'll do next is we'll do a movie classification on IMDB dataset. So you are going to do a sentiment analysis. So there's another principles that you're going to learn, something called sentiments. So you're going to do a sentiment analysis. So basically we are going to say the movie is good or bad. So that's our plan, right? Yeah, so start from the beginning. So we started discussing about NLP, the different options you have, and these are some of the applications available, and we talk about NLTK, and these are some of the principles. Sentence tokenization, word tokenization, lemmatization and stemming, and yeah, so then the stop words and regex, and then the bag of words, and how we do bag of words, and then TF-IDF, and finally the principle that we're using here. All right, that makes a lot of sense. So now I think we can go into implementing our code, right? For that, I'll be using Google Colabs. So we go to Google Colabs. If you never use Google Colabs, make sure you have a Google account. That's all you need. Okay, and once you go there, you guys can, if you are already registered, you can see whatever your documents. Yeah, so you have to notebook. So I'm going to open up a new notebook. Right, so the cool thing about Colabs is most of the things are already installed, so you don't have to do much of work in that sense. Already you are good to start with things, which is cool. See, you get a nice interface, and also this might have GPU capabilities also, which is also quite nice, right? Quite nice. Which is good when you're starting off with machine learning, right? So okay, and yeah, that's basically it. And also if you go to the Colab homepage, you'll find a lot of interesting things, a lot of tutorials, a lot of experiments that you can run, right? So please do practice this. So I cancel this, you go here. Okay, so once you go here, there's some nice tutorials for you to start with. Yeah, so this also works like notebooks. Everything here in Colabs is a notebook. So you can do everything. You can run this, and you can get this figure if you don't like it. So if you say I don't like this, okay, and then you can run this. So then you see that things changes. So everything is yeah. So yeah. So maybe it's not owned by me. Maybe that's not it's running anyway. So that you can do. All right. So and also a lot of other examples are provided. Right. So you can run them as you wish. Right. Right. So this is the starting point. So you can save this. This is IPython notebook. Okay. So all right. So I'm going to name this as this is movie classification. It's a binary classification or movie sentiment analysis. So I'm going to get the sentiments. All right. So that's saved. I can so in here basically you can check where it's connected, and this is one cell, so you can add any number of cells like this, and you can add text if you're going to write notes, blah blah blah. So I can delete this one, I don't need that, so I can put a note, so I can even share this with you. This is this tutorial explains this tutorial explains about movie classification, mainly a sentiment analysis, good or bad analysis using TensorFlow, and we use different techniques in TensorFlow, and also we use as NLP. All right, okay. Fine. So you can put a nice, okay, sorry, I don't need this. Okay, if you do a shift enter, that will go to the next slide. All right, so again, I would try to put in text. First, we'll check to if TensorFlow is not there, we'll install TensorFlow. All right, so to install TensorFlow, you have to run a command. So always when you're running commands in IPython notebook, you have to use exclamation mark. So I can run even commands like pwd, right? So it will give me the present working directory, right? Even though I don't have access to the underlying operating system, it should give me the necessary information. Yeah, so I'm in that content. Yeah, content folder, and also I can do a list. So those things are not that difficult to understand. So I will do a list here. Yeah, so I can get whatever the files inside this directory. So there's a sample data file. So if I do a ls minus al, I can get more information about it. Yeah, so so basically you get that information. So I don't need this. So just for you to understand. So to install, what I'm going to do is I do a pip install install TensorFlow. All right, so that's the command. So if it is installed, it will give the message, it's already installed. So that's why it says requirement already satisfied. So I don't have any problem of dealing with that. All right. So once that is done, next we can probably import TensorFlow. So I'll do those basic I'll do those basic commands. So I would like to add the text section. So here what I'm going to do is do the necessary inputs. Right. Okay, so the first thing should be import numpy as np. Okay, that's fine. And also I will import TensorFlow, which is the most important library here, right? And also I might need something called TensorFlow Hub. So I'm going to go there for a moment. TensorFlow Hub. All right, beside. Okay, if you go here, it's a library, right? It's contains a lot of libraries, which having, say as an example, is called consumption of usable libraries, right? They are already trained. That's important thing. And also generalized, and this will speed up our training. So you can do some nice videos you can watch. So your project especially, you have to use these reusable models. So I also once explained that you can save your models. This is a bit different, right? So, but these models can be used as an example. See, this is a model, that this is URL. There are some models, NNLM models. So these can be used. So you can do the same thing here. So I need to basically install these two, TensorFlow Hub, and also I need to install another tool called Nightly, and I can install this TensorFlow other things as well. So this will be the right way to do. So I'm going to copy this as well, and I'll paste it here. Alright, so I'll install TensorFlow Hub, and apart from that I will install this one, which is called TFDS Nightly. That's also important because we are using this something called TensorFlow datasets. So that's also, if you search, you can find out. So we don't have to download any of the datasets. sorry. All right, so if you go here, there's a lot of data for us to consume, right? So again, everything is explained here, how to get these data sets, and you can see get this models data sets loaded. So there's a library TFDS load function, and you can get the library. And once you go here, there's a catalog that you can use. So there's a lot of data. This is a We are living in a very interesting time, right? So there are all these interesting data. There's already preloaded. It's quite easy to do things. So there are audio data, image data. So embedding projects, like, so these are the ways to find out this data sets. Quite easy, right? So there are a lot of image data. Image processing is so huge. Object detection data, COCO model. So this COCO one is so famous. All right, and all the features and everything is properly explained here. See, and actually, yeah, and also summarization data is there, Reddit data is there, scientific papers there, and then the text. So what we require is this one, IMDB reviews. So it's a large movie review database. This is a data set, binary sentiment classification. So it's a binary sentiment using, and 25,000 highly colored movies for training, and 25,000 for testing. And so this is how you're loading it. And the description is also given. The home page, Stanford University have collected it, and the versions are there, download to 80 MB data sites. So all these things are properly given. So we can split it in this way if needed, and yeah, some other information is provided. All right, so we'll come to this bit later. Okay, so now what we have to do is we have to continue in our importing. So then what I have to do is import TensorFlow Hub, because now I need the TensorFlow Hub to reuse the TensorFlow Hub to reuse those, reuse the models, right? Hub, and then I have to import the TensorFlow databases, right? So of course you can copy these things from TensorFlow datasets, sorry, not databases, datasets, and I will normally use the TFDS. Right. So that is important. So I will run this. Yeah, so I haven't made a queue. If I made a queue here in install, this messages won't appear. It will not verbose everything. Okay, there's one they're installing. Okay, there is a problem. TensorFlow Hub is not there. Let me check. Okay, alright, TensorFlow Hub. Yeah, yeah, this is the issue. So what I'm going to do is I'm going to remove this one, and I'm going to type in do a queue also, TensorFlow. I will put the hub. Yeah, so it's there, right? So I don't think the problem will reappear. All right. Same problem. Okay. No module name TensorFlow Hub. Okay, let me check. Alright, I'll remove this for a moment. I'll come back. Alright, it worked fine. I think it's my mistake. So see, if I run this, so now it's running inside, so you can see no issues. So everything works fine. Alright, so now what I have to do, I have to so everything is properly imported. So next what I have to do is I have to check my versions, if the versions are correct, especially the TensorFlow version. So not going to write everything this time, so I will checking for versions. Alright, so that will do. Right, that's good. Okay, right. Checking for versions. Alright, so what I have to do is I have to print. Okay, I'm going to get the TensorFlow version. So this is the command for that, and also I would like to get the hub version printed. And also I would like to know whether the GPU is available, because it's not my machine, but this is the Colab. They might have GPU, so that's if condition. If it is available, it will print as GPU is available. So let me run this. Alright, so the version, which is cool. Right, so you can see the TensorFlow version. Is 2. So as you can see, it's 2.2. Hub version is 0.8, and GPU is not available. Unfortunately, it's not available. It's okay. Yeah. So if you want, you can get the GPU available notebook as well. All right. So that part is clear. So now I need to download the IMDB dataset. All right. So I'm going to go to the next step. All right. So this is the step where we download the dataset. So so if you want to get some information later and share this notebook, IMDB dataset is TensorFlow dataset. Okay, I'm going to add an image also for fun. Let me check adding image. I want to give the image scan. So it's not going to work. I know I might be able to work. Let me check. Alright. Cool if you get the text. Alright, bad. So I haven't tried that earlier. That's the issue. It's okay. Don't worry about the rest of the code. Alright, so now I need to get the data set. So when you are getting the data set, alright, there are a lot of things you can do here, right? So as an example, you can simply, alright, I forgot to mention, I'm just going to run this. If you want to find out what are the builders which are available, if I want to get the builders available, right, so I have these builders which are available in the hub, so that's fine. So I just run back again. All right. All right, now what I'll do, I will directly go to the implementation. So the next step is to get the data. So here, what's happening, I will copy the code rather than writing this. So you will have a train data set, validation data set, and a test data set. So these three are important, and we are using the TFDS load function, and the parameters would be, the first one would be the name. So name of the data set is IMDB reviews, and we are splitting it. We are getting the training data set 60%, and then we are having a test data set at the rest. So that's what we are doing. So basically, we are splitting into 60-40. So 15 samples for training and 10,000 samples for validation, and then 25 uh, samples for testing. So that's basically the loading of the data set. So we'll run this and see everything is fine. So they are downloading. So this is important. So there are 80 MB files, if you can remember. So so the details were there, 80 MB. Yeah, so all that goes fine. Still it's running, guys. Still it's running. All right. Still working. Okay, we give it a time. I don't think it will take a long time to run this. But remember one thing, that there are so many other ways of getting the data. So I can show you another method. So you can do it in this way as well. So you can get the load data set, split it to train and test only. That's also is possible, right? So there are so many different ways of getting it done, right? So I'm not going to run this. That might confuse things. All right, so that part is done. So data set is loaded. It's loaded to root TensorFlow data sets, blah blah blah. Right, so they hereafter in the notebook we are basically using this data, right? So now what I'm going to do, we can now explore the data a bit, right? So we are going to explore the data a bit, right? So to do that, so we are going to have this text here. We are going to explore the data. We are going to explore the data. So basically, what you have is here. Try to understand these are all example of a sentence, right? So the sentence is not pre-processed. So the label is an integer value of either 0 or 1. So that's basically what you have to understand, because it's not processed yet, right? So what I'm going to do is I'm going to get the train examples, train data, right? So this is the variable. So I'm using that variable and trying to do this there. Okay. That could do. Right. So basically what I'm going to do is to get the train data set, and I'm going to get the first 10 examples. So I'm going to get a batch of 10 records. So this is the command train data batch, right? 10, right? 10 examples, first example, 10 examples. So we have to run this several iterations. So to complete the statement, so I'm going to get this function. So basically I will go through this iteration, and also you get the train example batch and the labels batch. So first we look at the examples batch, and we'll try to have a look at the type of the data, right? So there's a TensorFlow. Later on we'll try to understand these things. So there's a tensor used as a string type of array, and then you can see this is absolutely terrible movie, don't be lured into Christopher Walken. So I'm not sure which is this movie, blah blah blah. So you have one record explaining all these things, and then I have been a fall asleep during films, but this is usually due to a combination of things, blah blah blah. All right, so you have all this information, right? And also we'll try to print the labels as well, representing these 10 examples, right? So that's what you have here, train labels batch. So it should say whether binary value, whether it's 1 or 0, meaning 0 is a bad movie, 1 is a good movie, right? So okay, so as you can see, this is an absolute terrible, so 0. Then I have been known to fall asleep, 0. This is a kind of film for snowy Sunday afternoon, bad. Fourth one, this is the kind of film for, okay, that's good, no? The world can go ahead with their own business. Okay, fine. The next one, As others I mentioned, all the women that go nude in the film are mostly absolute gorgeous. Alright, that's good. It's a film which should have been anybody interested. That's also good. So those are the four reviews which are good. So that's why you have, or three which are good, and others are bad. Alright, so it's clear to you guys. So those are the labels, right? Right. So now, okay, now we come to the important part. So we have to now build the model, right? So this is where the magic happens, in the sense like this is, sorry, I have to build the text. So build the model. So in this example, yeah, sorry, not in this case, we have to use the TensorFlow hub. Yeah, so build the model. So basically, we are going to use a neural network, right? And the important questions, we have all discussed this. So neural network is created by stacking layers. This requires three main decisions: how to represent the text. So it's of course two vectors, word to vec. How many layers in the model? So we can use three, of course, the initial at least. How many hidden units for each layer? It depends, right? It's completely depends on the problem, so we can try it out. And then so we have to we get context from sentences. So we already know about it, right? So we have to convert it to zeros and one to get our sentiments. So one represent text to convert is embedding vectors. So we have discussed it in our embedding vectors in our example. We can use pre-trained models. So that's what we are going to do. So guys, so we are going to use a pre-trained models. So we don't have to train the text. So the advantage using this pre-trained embedding is, because there are we are given word corpuses and they have trained it. So when we get new words in our model, so it automatically works. So we don't have to bother too much. So all right. All right, so we don't have to worry about the text pre-processing. That will be done. So truly, like if you are a good machine learning engineer, to learn the machine learning, right? So you might have to build your own models, but if you're an engineer, you can use these models. So you have to do things faster and you have to use accurate models. So no harm of using this, right? So in our case also, you have to use them. And also we can benefit from transfer learning, and they use something called transfer learning. Transfer learning is basically a model where you can use some trained probabilistic models to train your model. So in very short, that's what's happening. So that we can use, and also the embeddings has a fixed size, so it's simpler to process. So that's also an advantage. So I told you where to get these pre-trained models. So that's from the TensorFlow hub. So yeah, you're also using the same thing. So there are a lot of pre-trained models out there, and remember these pre-trained models are basically trained with a lot of data, big data corpuses. That's one of the core concerns that you have to understand. All right, so as you can see here, guys, so there's a lot of important data sets. See, much larger model with 1 million vocabulary size and 50 million dimensions, 50 dimensions, so which is quite exciting. But in our case, we are using Keras, so you know Keras. We used Keras in the previous case, and we're using existing TensorFlow hub. And for that we are building using a particular model. So if I try to show you the model from the TensorFlow hub, I go here. So this is the URL. Okay, so this is the one, the model. This is a token-based text embedding trained English Google News 130 GB corpus, right? So it's a really good one. This model is the same model 2.420, and alright, matrix blah blah, I don't need that. So this is how you can load that one as embedding. So we can use it in Keras. So basically you are going to model a neural network. So the first model for the less layer would be the hub layer, and we'll have another two layers, especially one hidden layer and then one output layer. So that's basically what you do. All right, so we come back. So then, so we get our text. There's a lot of text there. That's all fine. Right, so now we'll run our coding. So basically we have to get the embedding, right? So it's all fine, no issues. So then I want to get the hub layer, right? So hub layer setup. So this is a hub layer, Keras layer. Yeah, so that's also fine. Let me check that. All right, that's also fine. And I'm going to get some information out of it, right? Part of it. Okay, then on this, so this should give out, yeah, some information. So now see, it's all embeddings. It's a vector, so we are not going to play with that anymore, right? Okay, now to the important part, which we are going to build our neural model. Build the neural model. So you are going to use, guys, so rather than using pure TensorFlow, it's easy to do it through Keras. We love Keras. All right, so now to do that, of course, we have to use sequential. We use sequential. Okay, then next we have to add the hub layer, and then, okay, I'm going to write this down. Model add. All right, so I want to add the previous hub layer. Okay, it started there, and then I will add another dense layer. Oops, it should be tf dot dense. All right, so not tf dense, it should be Keras. All right, and then layers, and then dense. Okay, this time I will add 16 node. You can start at 20 if you want to. And the activation function, we can use sigmoid or relu, but here normally it's a hidden layer. I will use relu. Later on, if needed, we can change the structure. All right, guys. And finally, we need to add the output layer, tf Keras, same thing, layers, dense. All right, and I'll put one. I will not put the activation. We don't need that. And also, finally, just to get the summary, so this is important part, that's why I typed it. All right, now we see our network. So sequential, first the hub layer, these are the parameters, dense. All right, everything is fine. All right, so here first layer is a TensorFlow hub layer, guys. Try to understand. This layer uses the pre-trained model from which are shown. This resulting dimensions are given, and then the fixed length output vector, which is a fully connected dense layer of 16 hidden nodes, and last layer is a single output node, right? All right, that's cool. So next what we have to do is, once we develop a model, before training phase, we have to set up the loss function and the optimizer. So you know that the loss function and the gradient is needed, optimizer is needed. All right, so basically we can use here as the loss function, we can use a binary one. So we use binary cross entropy loss function. It is good here. And also we can use Adam optimizer, so that would do. And we can use the measurement as accuracy, so it can have idea about the model accuracy. Okay, now let's check. Yeah, everything is fine. Okay, now comes to the phase where we guys have to do the training, right? So training, it's not the hardest thing in the sense of writing code, but of course, depending on your data set, it might take a long time. So what we are going to do is, we learn about epochs and batch sizes. We are going to have a control environment of 20 epochs and batch sizes of 512 in the batch, right? So, and also the output will put into X train and Y train. So let me run this. or train the model. Depending on the situation, it can take a bit of a time. So we'll see how good the collabs here. All right, it's running. First one is running, so it had to wait a bit. All right, so we continue. So we'll wait until it evaluates, and then we go to the next step. It's running in the background. I don't care, and I will write code to evaluate the model. Evaluate the model. All right. So for the evaluation, basically just to get the loss and the accuracy. It's not going to be that hard, right? So I'm going to copy the code, guys. So I'm not going to explain the code here. It might not be that difficult to understand. Right. Okay, so this will be the code. I'm not going to run it yet because I will wait a bit until yeah, this is cleared. Then we can, because this is trained, so I can then evaluate. So it's 17th epoch, so it might take a bit of time, so it's okay. So I'm looking for good accuracy because we used a pre-trained model, which is this one. So that should be good, right? And so if you're wondering where our IMDB data comes in, so we are using here in the code train data, right? So train data, and we shuffled it, and then we break it to batches, and we are sending to several iteration epochs. And also for the validation, we use the validation data. So at the moment, there's no testing done, guys. Please understand that. All right, so it's done. Everything is good. Now we'll check the accuracy and the loss. Oops, not bad. 0.85. Again, not that good, the best, right? Not the best. But we try to improve. So your target is to improve this, right? So to improve this, do some changes and try to improve this. So you can use some advanced approach and do that. All right. So now everything seems to be fine. So now what we have to do is probably do a prediction, right? So we came all throughout. So to do some prediction. So now is the prediction time. So we can check a sentiment prediction time. Right. We'll see. I'm not sure whether this works. Right. Hopefully. So the command is model.predict. Yes, you have it. I will say something like, oh, what a terrible, what a bad movie. So bad movie. What a bad movie. Yeah. So they should, guys, we should get the sentiment of negative, right? So it should be near to 0. What a crazy movie. Crazy, maybe, I don't know. Maybe it's good or bad, we'll just check, right? Okay, we'll say what will be the output. Oops, that's bad. Right, what is the problem? Just give it a second. I'll come back. Yeah, so I missed the square bracket. So this, oh, what a crazy movie. So now, meaning crazy, they have taken, I believe they have taken into understanding of in the good side. All right, so maybe it cannot identify it proper. So what I'll do is, what a bad movie. All right, I'll do that. I'll try to do something like this. This is the worst movie I have ever seen. Alright, so it gets some net value near to 1, so maybe minus value, no? So that shows that it's a bad sentiment, right? All right, so that's basically gives you kind of idea about how you do the sentiment. All right. All right, so you can play with this and try to get these accuracy values high. That's what you guys have to do now. All right, so hope it's clear, right? So try to build models like this. You can use a lot of data sets and everything. So you can use pre-trained models, and you have learned about NLP. So there are so much of things that you can do on NLP, like for your projects also. So hope you guys are good with it. All right, thank you, and we'll next see the next lecture. And also, it's a reminder for your project. So please work on that assignment, right? So now you know how to work with this collabs as well. So it's very easy. So you have all these options. You can use Jupyter, you can use IPython, and you can use Colabs, and you can use GPU facilities. All these things are there, right? So yeah. So all these nice options are there. So and also I'll share this notebook if you guys can get it through, right? Okay, so I'll share this. All right, guys. Thank you.